Everyday Mathematics. Today we are still on the 2024 University of Florida Integration B qualifying round. And this next phase is what we call part 2. We'll be looking at problem number 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So these are very interesting problems. I like to just take time to solve them systematically in a way that is easy to understand. If you have any questions regarding how we may have been able to solve some of the problems, we do encourage you to reach out to us via the comment section. We'll always endeavor to get back to you. Now, if, for those of us who are here for the first or second time and haven't subscribed to our channel, we do really encourage you to consider subscribing to our channel. Without much ado, let's move forward to the solution session of this video. On to problem number 11. The limit as n tends to infinity of the integral from x equals to 0 to infinity of 1 over 1 plus x over n to the power n. So what do we do here? Let's close our eyes for a minute and ignore the limit. So, and then we say, let y be equal to x over n. So dy dx would be equal to 1 over n, meaning that for a minute we have n dy being equal to something that can be used to substitute for x, for dx. And obviously when x tends to 0, y tends to 0. When x tends to infinity, y would also tend to that. So that our problem, limit as n tends to infinity would be equal to limit as n tends to infinity 0 to infinity 1 over 1 plus y to the n, something like that. And then we can pull the n out so that we have right. And what happens next? We have limit as n tends to infinity of n negative 1 over n minus 1, 1 over 1 plus y, n minus 1, like that. And we can see as y tends to infinity, this part tends to 0. As I tends to 0, this part tends to 1. So in essence, we have limit as y tends to infinity of negative 1 and minus 1, that's 1, minus limit as y tends to 0 of the same value we have there. So this one tends to 0 and this tends to negative 1 over n minus 1. And so let's continue and see how this. Eventually, now we do have a limit as n tends to infinity of n over n minus 1, which is limit as n tends to infinity of 1 over 1 minus 1 over n. And we can see here that this part here tends to 0 in that instance. So we have 1. Therefore, limit as n tends to infinity of the integral from x equals to 0 to infinity of 1 over 1 plus x over n to the power n is equals to 1. And that is our answer. Problem number 12 happens to be the definite integral from x equals to negative 1 to x equals to positive 1 of negative open bracket x cubed over 3 minus x times sine of pi x. So how do we do this? I would begin by just splitting this into two separate integrals. And so here we have negative 1 to 1 x cubed over 3 sine pi x x sine pi x. So there's suddenly a negative here. As we can see here, between negative 1 and 0, we have the same value as what we have 0 to 1, and the same thing here. So the best thing for us to do is to say, okay, this is twice the integral from x equals x equals to 0 to 1 of negative x cubed over 3 sine pi x plus 2 0 to 1 x sine pi x. In other words, these functions are even, or the integrand is even, and is symmetrical about 0. Okay, so I would like to exploit integration by parts here. And how do I do that? First, I would like to make these x terms the same so that I don't have to deal with two integrals. I want to make one integral out of these two separate things. So what I can do is I can say, okay, this is, I'll pull the negative sign out, and so we have 2, 0, 1, x cubed, 3, and sine pi x is the same as the derivative of cosine pi x negative over pi. And then here, x is the same as the derivative of x squared over 2, and then we have. What do we do next? We're going to use integration by parts. And just to remind us, what is integration by parts? Integration by parts is an integral such that when you have a product of function v and the derivative of function u, we have uv, and integrate that, we have uv minus u dv. So this is a nice linchpin. So that now what we have here, our uv is going to be equal to negative x cubed, and then maybe we can bring pi there. So we have cosine pi. Now this negative here also interacts with this, so we have positive pi x 0, 1 minus 2 over 3 pi 0, 1 cosine of pi x derivative of x cube. And then focusing on this part here, we have uv is going to be equal to this 2 and this 2 here interact, so we have just x squared sine pi x 0, 1 0 to 1 x squared times the derivative of sine pi x. Okay, so this is good, this is good. We've come to a point where we have 2x cubed over 3 pi cosine of pi x 0, 1, and we have minus 2 3 pi 0, 1 cosine pi x, the derivative of x cube dx, and then we said we did have plus x squared sine pi x 0, 1 minus sine of derivative of sine of pi of x. Okay, so let's keep going. What do we see here is interesting. Here we have a 3 pi cosine of pi 0, and then what do we see here? So we have 2 over 3 pi 0, 1 3x squared cosine of pi x plus minus 0 minus 0, 1 x squared cosine, there's a pi here, pi x. So this goes to negative 1, and so we have negative 2 over 3 pi, and we have minus 2 over 3 pi times 3, 0, 1 x squared cosine of pi x, and this goes to 0 as well, so we have minus 0, 1 x squared, there is a pi here, cosine of pi x. And so we now have negative 2 over 3 pi, negative, this 3 and 3 cancel, so we have 2 over pi plus x squared cosine of pi x. So now our focus can just be on this integral here, and then we can proceed from there. So we've come to a point where our problem is negative 2 pi over 3 minus 2 over pi plus pi times the integral from 0 to 1 x squared times cosine of pi x. And we see that this is now what we're going to focus. In fact, I can just draw a blue rectangle over it. And now say that 0, 1 x squared cosine of pi x dx is the same as 0 to 1 x squared, the derivative of sine pi x over pi. And we shall use the same integration by parts, so we have x squared over pi sine pi x 0, 1 minus 1 over pi. We're pulling the constant out. And then we have 0 to 1 sine pi x times the derivative of x squared. So as we can see, here we have 1 over pi sine of pi minus 0. Dealing with this, minus 1 over pi 2x sine pi over x. So this goes to 0, and so we have negative 1 over pi 2x 0, 1 sine pi x, which is the same as 2 over pi 0 to 1 x, the derivative of cosine pi x negative over pi. And we can use integration by parts again, so our uv, this negative and this negative interact, so we have 2 over pi squared cosine, there is an x obviously here, pi x 0, 1 minus 2 pi squared cosine pi x, the derivative of x. Okay. So we've come to a point where we have 2x pi squared cosine pi x 0, 1 minus 2 pi squared 0 to 1 cosine pi x, the derivative of x. So this is the same as 2 pi squared cosine of pi, okay, minus 0 minus 2 pi squared. This becomes 1, so we have 0 to 1 cosine of pi x. You may want to rewrite something here correctly. And so we have in essence, what we have is this goes to negative 1, so we have negative 2 pi squared minus 2 pi squared 0 cosine pi x, and what do we have? We do have and this becomes, integrating this becomes sine pi x over pi 0 1, which is negative 2 pi squared minus 2 pi squared sine pi over pi minus sine 0 over pi. So this is 0, this is also 0. So this equals to negative 2 over pi squared. Now, initially we had said that our problem, negative 1 to positive 1, negative x cubed over 3 minus x sine pi x was equal to negative 2 over 3 pi minus 2 over pi plus pi times the integral from 0 to 1 x squared cosine of pi x. And we've seen this to be negative 2 over pi squared. Therefore, this becomes 2 over 3 pi negative 2 over pi plus pi negative 2 over pi squared, and this becomes negative 2 over 3 pi plus 4 over pi cubed plus 2 over pi. This and this interact, so we have 4 over pi cubed plus 3 pi in the denominator. We have negative 2 plus 6. So this becomes 4 over pi cubed plus 4 over 3 pi. In other words, the big integral from negative 1 to positive 1 of negative x to the power 3 over 3 minus x sine of pi x is equal to 4 over pi cubed plus 4 over 3 pi. That's the answer. So problem number 13 happens to be a definite integral or from x equals to 0 to x equals to 1 of 1 minus x to the power 7 over 1 minus x. So the way I could maybe rewrite this, since x lies between 0 and 1, we can rewrite this as, let's put bracket there, 1 minus x. So we know that the summation from k equals to 0 to infinity of x to the power k is equals to 1 over 1 minus x. In the event x lies between negative 1 positive 1. So the absolute value when x is less than 1, right? So here we have 0 to 1, 1 minus x to the 7 times the summation from k equals to 0 to infinity of x to the k. Now what do we do? The integration of, let's even not go there fast. So we have, this is same as x to the k minus and we know that the integration of a sum of things is the same as the sum of the integration of the independent items. So we can decide to just reverse the signs. So we have this becomes 1 over k plus 1 x k plus 1 minus 1 over 8 plus k 0 to 1, which essentially equals to -1 minus 1 over k plus 8, right? So if our integral has gotten us to this interesting sum, this is really, we have 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 6 plus 1 over 7 plus 1 over 8 plus and so on and so on, minus 1 over 8 plus 1 over 9 plus 1 over 10 and so on and so on. So we see that this part here cancels with this part, and so we are left with the summation from k equals to 1 to k equals to 7 rather, when of 1 over k. So we have from k equals to 1 to 7 of 1 over k, and that is our answer. So maybe we can write it nicely. We say the integration from x equals 0 to 1 of 1 minus x to the 7 is the same as or the harmonic function 7. So that is our answer. Number 14 is the definite integral from x equals to 4 to x tending to infinity of 2x over x minus 1 times x minus 2 times x minus 3. So what do we do? I think the first thing we can do here is to express this as partial fractions. So we can say 2x minus 1 over x minus 1, x minus 2, x minus 3 is the same as a constant, in other words, a polynomial 1 degree less than the denominator, plus b plus c x minus 3. So in other words, 2x minus 1 is equivalent to a denominator happens to be this time divided by x minus 1 times a, so we have x minus 2 x minus 3 plus b x minus 1 x minus 3 plus c x minus 1 x minus 2. When x equals to 1, we substitute x minus 1, x equals to 1 into that, we get 2 minus 1, which is positive 1. And in other words, that is equivalent to, we see this other part becomes 0, so we only have a times negative 1 times negative 2, which means that a equals to a half. When x equals to 2, we substitute 2 here, we get 4 minus 1, which is 3. This is equivalent to, we see this part becomes 0 and this part becomes 0, so we get b times 1 times negative 1, meaning that b is equal to negative 3. When x equals to 3, that means that when we substitute it here, we get 6 minus 1, so 5 is equivalent to c, because this part is 0, this part is 0, so we have c times 1 times 2 rather, times 1. In other words, c equals to 5 over 2. Okay? Since we say that 2x minus 1 over x minus 1, x minus 2, x minus 3 is equivalent to a over x minus 1 plus b over x minus 2 plus c over x minus 3, and we saw that a was equal to e, and c was equal to 5 over 2, then our integral from x equals to 4 to x equals to infinity is of our original integrand is the same as the same integral of x minus 1 minus 3 x minus 2 plus 5 over 2 1 over x minus 3, the same as a half natural logarithm of x minus 1 3 natural logarithm of x minus 2 plus 5 over 2 natural logarithm of x minus 3, all in bracket 4 to infinity. So we can say that this is the same as log of x minus 1 x minus 3 to the power 5 log of x minus 2 to the power 3. We can play around a little bit more because we know that 3 is equals to a half plus 5 over 2, right? Then it means that this is the same as log of x minus 1 over 2 x minus 3 5 over x minus 2 5. And so limit as x tends to infinity of the natural logarithm of big bracket x minus 1 over x minus 2 plus log big bracket minus limit x tends to 4 of log of square root of x minus 1 x3 to the power 5 over x minus 2 to the power say something like that, or x to the 6. So as we can see, if we divide the numerator, this can easily become log square root of 1 over x, 2 over x, and the same thing here. So essentially this can go 10 to 1 as x tends to infinity. This also tends to 1, so we have a 0 minus, and here we have natural logarithm of as square root of 3 1 2 2 to the power 5 is reciprocal, so whatever we have in the denominator is 8 over root 3. So in other words, from 4 to infinity, 2x minus 1 over x minus 1, x minus 2, x minus 3 is the same as the natural logarithm of 8 over root 3. That's the answer. So problem number 15, the indefinite integral of 1 over 2x squared plus x to the 4. This is obviously just the same as 1 plus x squared. 1 over the square of 1 plus x squared. And when faced with such problem, we can just say let x be equal to the tangent of theta, meaning that dx to theta is equal to sec theta. And so dx can be substituted off using sec squared theta d theta. And therefore, our problem becomes 1 plus tangent square theta dx is sec square theta d theta. So, and there's a square there. So we have 1 over sec to the 4th theta, because 1 plus tangent square theta is equivalent to sec square theta. This is an important relation. So this power 2 leaves 2 here, so we are left with the integral of 1 over sec square theta, which is the same as the integral of cosine square theta. We know that cosine squared theta is the same as half of cosine 2 theta plus 1. So that means our integral is the same as a half cosine of 2 theta plus 1. So now that we have half cosine of 2 theta plus 1 is the same as half over half sine 2 theta plus the integration constant. So this is a quarter Sine 2 theta is the same as twice sine theta cosine theta plus a half theta plus c. 1, this goes twice, so we have a half sine theta cosine theta plus a half theta plus the integration constant. But we said that x equals to tangent of theta. So what does that mean? It means that when we have a triangle of base angle theta, since tangent is the opposite over the adjacent, and we have x being cotangent of theta, that means that the opposite will be x, adjacent will be 1, and therefore the hypotenuse will be 1 plus x squared. And therefore sine theta will be equal to x over the square root of 1 plus x squared, and cosine theta will be equal to 1 over square root of 1 plus x squared. In other words, since our problem is half sine theta times cosine of theta plus a half theta plus c, it means we have a half x over square root of 1 plus x squared, 1 over square root of 1 plus x squared, plus a half. Since x is equal to tangent of theta, it means that theta is the arctan or the arctangent of x. So this becomes a half, we can pull half out, x over 1 plus x squared plus the arctangent of x plus c. So what do we mean? We mean that our integral of 1 over 1 plus 2x squared plus x to the fourth is equals to a half x 1 plus x squared plus the arctangent of x plus c. And that is our answer. Number 16 is a tricky problem, but all the same solvable. It's the definite integral from x equals to 0 to x equals to pi of x times sine to the fourth x over sine to the fourth x plus cosine to the fourth of x. Now, how do we solve this problem? The first step for us is to split this integral into two separate domains. That's from x equals to 0 to x equals to pi over 2, and then from pi over 2 to pi. And this is how we do it. So first, from 0 to pi over 2, we have x sine 4x over sine cosine, and then from pi over 2 to pi over let's focus on this guy. I want us to focus on that. And what we'll do is we'll say let u be equal to x minus pi over 2. What does that mean? It means that du dx equals to 1, and so we can substitute for dx with du. X equals to pi over 2, u equals to 0 when x equals to pi, u equals to pi over 2. And so just to distinguish what we are doing here, let's use a different color. So we are focusing on this integral here. So it means that from pi over 2 to pi x sine to the fourth of x over sine to the fourth of x plus cosine to the fourth of x becomes 0 to pi over 2 in the u domain. And from here we see that x is the same as u plus pi over 2. Sine becomes u plus pi over 2 plus cosine so what is sine u plus pi over 2 is the same as sine. Let's delete this. This is the same as sine of u cosine of pi over 2 plus sine pi over 2 cosine of u. This goes to 0, so we just get cosine of u. And so sine 4 of u plus pi over 2 is equals cosine to the 4th of u. Okay, what about cosine rather? Okay, cosine of u plus pi over 4 is the same as cosine of u cosine of pi over 2 minus sine of u sine 2. This guy goes to 0, so we get negative sine over u. However, cosine to the 4th of u plus pi over 2 is equal to sine to the 4th of u. And so our problem from 0 to pi over 2 of u plus pi over 2 sine 4th u plus pi over 2 over sine to the 4th of u plus pi over 2 plus cosine to the 4th of u plus pi over 2 is equals to 0 to pi over 2 u plus pi over 2 cosine to the 4th over sine plus okay, so this is an important relation that we've landed on. And so our original problem, which was equal to 0 to pi over 2 x sine to the 4th x over sine 4th x plus cosine 4th of x plus pi over 2 to pi of x over sine 4th x plus it is the same as 0 to pi over 2 x plus pi over 2 cosine so we can now collect like terms since the denominator is the same, and we'll say that we have x sine fourth plus cosine to the fourth over sine plus pi over 2 cosine plus cosine. Right. And we see that this and this cancel. So which is, we've now come to a point where we have 0 to pi over 2 of the integral of x plus pi over 2 integral from 0 to pi over 2 of cosine of that over right. And we could take a small detour here and focus on the second integral, specifically here. So if we kind of do the same thing and say let u be equal to x minus pi over 2, then it means du dx is equals to 1, and therefore du can be used to substitute for dx, right? And so looking at that, when x equals to 0, we see that u equals to negative pi over 2. When x equals to pi over 2, u equals to 0. So in other words, our integral 0 to pi over 2 of cosine of to the fourth of x over sine to the fourth of x plus cosine to the fourth of x would be equal to negative pi over 2 to 0 of cosine to the fourth of u plus pi over 2 and sine to the fourth of u plus pi over 2 plus cosine to the fourth of u plus pi over 2 du. And we've seen that this becomes sine, this part becomes sine, and so cosine and sine interchange. So in other words, we do have negative that 0, and we have sine over cosine plus sine, right? So that when we say y equals to negative u, we see that dy is equals to negative du, or vice versa. And so this becomes pi over 2, 0, and since we have the power 4, we have y over cosine 4y plus sine to the 4y negative dy. So this sign here allows us to flip the signs back. So we have sine to the 4 of y over cosine plus sine. Okay. And so in other words, what we have here is that 0 to pi over 2 cosine for x is the same as 0 to pi over 2 sine x over and so if this equals to I, it means that 2I is equals to the sum of the two integrals, which is sine to the fourth of x plus cosine to the fourth of x, And since the denominator is the same across the two integrands, and so this and this cancel, so this is the same as 0 to pi over 2, the integral of 1, which is x, 0 to pi over 2, which is equals to pi over 2. In other words, 0 to pi over 2, and this is I, is equals of cosine to the fourth of x over sine plus cosine to the fourth of x is equal to pi over 2 divided by 2, which is equals to pi over 4. Now, our original integral had brought us to, and let me just rewrite the entire integral so that there is no ambiguity in any way. So we have the integral from 0 to pi of x times sine to the power 4 of x sine to the power of x plus cosine to the fourth of x was the same as the integral from 0 to pi over 2 of x plus pi over 2 integral from 0 to pi over 2 cosine over sine okay. So this is the same as x squared over 2, 0 to pi over 2 plus pi over 2, and this is, we found this to be pi over 4, so times pi over 4. So this is the same as pi squared over 4 over 2 minus 0 plus pi squared over 8, and that means that we have pi squared over 8 plus pi squared over 8, which is pi squared over 4. Therefore, the integral from 0 to pi of x times sine to the fourth of x over sine to the fourth of x plus cosine to the fourth of x is equals to pi squared over 4. And that is our answer. Problem number 17, which is the definite integral from x equals to 0 to x equals to 8 of x equals to infinity of x to the power 4 minus 2x plus 1 over x to the power 8 minus 1. So this is actually interesting. How do we do that? First, I like to separate x to the 4 plus 1 over x to the 8 minus 1 minus integral from x equals 0 to infinity of 2x over x to the 8 minus 1. Now, difference of two squares here, so we have 0x to the 4 plus 1 over x to the 4 minus 1, x to the 4 plus 1, and as we can see, these and that cancel, minus 0 2x over x 8 minus 1 dx. So in other words, we have 0 to infinity 1 from 0 to infinity 2 of the integrals of from 0 to infinity of 1 over x to the 4th minus 1 minus 0 to infinity 2x over x 8 minus 1. If we say, just focusing on this integral here, and we can use another color, say let u be equal to x squared such that du is equal dx is equals to 2x, and therefore if we substitute for 2x dx with du, and as we can see, the limits remain the same. When x equals to 0, u is equals to 0. When x tends to infinity, u tends to infinity. So in other words, 0 to infinity 2x over x to the 8 minus 1 dx is the same as 0 to infinity of 1 over x to the u to the power 4 minus 1, like that. And so our original problem x to the power 4 minus 2x plus 1 over x to the 8 minus 1 from 0 to infinity was first of all split into 1 over x to the 4 right. But from this relationship here, we can see that this is the same as minus 1 over x to the 4 minus 1 dx. So this cancels and the problem goes to 0. And so what that tells us that from 0 to infinity, when we integrate x to the 4th minus 2x plus 1 over x to the 8 minus 1, that is the same as our 0. Problem number 18, which is the indefinite integral of sine of 20x plus sine of 24x over cosine of 20x plus cosine of 24x. Okay, I think what we can do is we see 20x is the same as 22x minus 2x. 24x is the same as 22x plus 2x. So we see a pattern here. If we take 22x, if we take this part to be a and this part to be b, we have sine of a plus b, a minus b. Let me delete it. Sine of a minus b plus sine of a plus b is equal to twice sine a cosine b. And similarly, cosine of a minus b plus cosine of a plus b is equal to 2 cosine a cosine b. In other words, sine of 20x plus sine of 24x all over cosine of 20x plus cosine of 24x is equal to twice sine of 20x of 22 rather x cosine of 2x over twice cosine of 22x cosine of 2x. So that and that cancel, that and that cancel. So we are left here with sine of 22x over cosine of 22x. And so our very interesting problem here of sine of 20x plus sine of 24x over cosine of 20x plus cosine of 24x integrated is the same as sine 22x over cosine of 22x. And we see the numerator to be the derivative, negative of derivative of 1 over 22 cosine of 22x. Right? And so we know previously that if we have the derivative of a function of x over the same function of x, this is the natural logarithm of fx plus c. So with that bag of tricky at hands, we have negative natural logarithm of cosine really 1 over 22 cosine of 22x plus c. And so our problem, sine of 20x plus sine of 24x all over cosine of 20x plus cosine of 24x is equals to negative 1 over 22 natural logarithm of cosine of 22x plus c. And that is our answer. So problem number 19 happens to be the indefinite integral of 1 over 1 minus cos of ax. So, wow, man, what is cos? Cos, so let's see, this is the same as the integral of 1 minus e to the ax plus e to the. So that's the definition of hyperbolic cosine. Okay. Now, what do we do? Multiply by 2 both the numerator and denominator. So we have 2 over 2 minus ex minus. If we multiply both the numerator and the denominator with e to the power ax, we have 2. And if we apply a negative here, we get that minus 2 ax plus 1, which is the same as, we pull the negative 2 out, we have eax over eax minus 1 squared. Okay, so say let u be equal to e to the x. We have du dx is equals to a eax, meaning that du over a is the same as e to the ax dx. Okay, so what does that mean? It means that 2 e to the ax over e to the ax minus 1 squared dx is the same as negative 2 1 over u minus 1 squared du a, which is negative 2 over a 1 over u minus 1 squared du, which is the same as 2 over a plus c. But u equals to e to the ax, using that. Therefore, the problem negative is equal to 2 over a plus c. We may want to take this problem back to the hyperbolic functions. I don't think we should labor in doing that, but in case you are hyper OCD and you want to do that, we can certainly do that. And how do we do that? We we can do it as follows. So we say that 1 minus cosh is equals to 2 over a ex minus 1 plus c. This could also be 2 over a 1 over ex minus 1 1 over a plus c, just 1. So this is a new constant we are creating. So this becomes 1 over a pulled out. We get e to the power ax plus 1 over e to the power ax minus 1 plus c1, and then multiply by negative e to the power ax over 2, both numerator and denominator. We get e ax over 2 plus e negative ax over 2 minus e ax over 2 minus, right, and so this can also be expressed as divide by 2, that way, divide by 2. So we do have what we call hyperbolic cosine ax in the numerator, hyperbolic sine in the denominator. So we get 1 over a cosh ax over 2 sinh ax over 2 plus c1, which is 1 over a hyperbolic cotangent over, right, and that is what you get by integrating that. Okay, let's proceed. Problem number 20 happens to be the definite integral from x equals to pi over 3 to x equals to 2 pi over 3 of 1 plus cosine of x over x plus sine of x plus x plus sine of x over 1 plus cosine of x. So let's play around with this problem. So we have, this is the same as integral from x equals to pi over 3 to x equals to 2 pi over 3 of the first part. There is a derivative of x plus sine of x over x plus sine of x. This. Okay, let's do it this way. This is x2 sine x over 2 cosine x over 2 over 1 plus twice cosine squared x over 2 minus 1. This will cancel. So when we have a function that consists of a numerator that is a derivative of the denominator, when you integrate that, it's easy to just say that is the same as log of the function in the denominator, and that's what we are doing here. Two pi over 3, we have x plus 2 sine x over 2 cosine x over 2 over 2 cosine squared x over 2. So we have natural logarithm of 2 pi over 3 plus sine of 2 pi over 3. It's log of pi over 3. integral from 2 pi over 3 to 2 pi over 3 sec squared x over 2 plus 2 on this 2 cancels, so we do have tangent of x over 2. Okay, and there's an x here. So we've come to a problem that has log of 2 pi over 3 plus sine 2 pi over 3 minus log of pi over 3 plus sine of pi over 3 0, not 0, but rather pi over 3 to 2 pi over 3 I have x sec x over 2 plus tangent x over 2. So we see that this is a derivative of this, and then right here we may have a derivative of x. So that's a product rule. And then using the rules of logarithm, we can just say this is same as log 2 pi over 3 plus sine of 2 pi over 3 should be root 3 over 2. And so we have pi over 3 minus root 3 over 2, or plus rather, root 3 over 2 plus the integral. We don't even have to label that much. We'll just say this is the same as x tangent of x over 2 from pi over 3 and this is the same as log of 4 pi plus 3 root 3 over 2 pi plus 3 root 3 plus 2 pi over 3 tangent of 2 pi over 6 which is just pi over 3 pi over 3 tangent pi over 6. So we have log of 4 pi plus 3 root 3 over 2 pi plus 3 root 3 plus 2 pi over 3 tangent of pi over 3 minus pi over 3 tangent of pi over 6 is log of 4 pi plus 3 root 3 over 2 pi plus 3 root 3 plus 2 pi over 3 tangent of pi over 3 is the same as root 3. Yes, so root 3 over 2 over half, right? Minus 1 over 3, which is the same as 1 over root 3. Okay, so we can pull pi over 3 out there. Pi over 3 to root 3 minus 1/3. And so denominator becomes √3, and therefore we have 6. So we have 5 left. Plus 5 pi over 3√3. And so our problem, 2 pi over 3 of 1 plus cosine of x over x plus sine of x plus the inverse of that, which is x plus sine of x over 1 plus cosine of x is equals to natural logarithm of 4 pi plus 3√3 plus 5 pi over 3√3 is the answer, ladies and gentlemen. So without much ado, it's been an absolute pleasure going through this set of problems. If you have any questions, any alternative solutions to these problems, we do really encourage you to reach out to us. If you do like what you're seeing, please don't hesitate to leave a like. Also, if you haven't subscribed to our channel, we do really I encourage you to consider subscribing to our channel. So without much ado, until next time, bye bye.